So this talk derives a little bit of some observations I've made using Brew in certainly totally different environments. So short things about me. Hello, I'm Henry. My company is Apfelwerk. I'm based in Hamburg, Germany. And so, yeah, it's my third time here at the conference. So everybody is doing that, downloading stuff from the web. So getting software is a vital feature that many of us using a computer with. And so it doesn't matter how we do this, manually or using a package manager or a script to install our software. However, installing software is crucial and essential for developers as well. And besides the common apps and IDEs, they need to install some extra stuff that we may have never heard of before. And so they do this often on their own and without any monkey, Jamf, whatever involved. So living behind a proxy, I think this is an interesting experience. So for some business reasons, organizations put developers and users behind a proxy in pretty firewalled networks. And in practice, downloading software there can become, an experience. So it may work one day very well. It could fail the other day or slow down a lot. So just think about developers have to be onboarded and everything is slow. No? So it turns out that in such regulated scenario, doing this can become quite stressful. So the developers start to battle against the existing rules. They are there for a reason, but and they have to get up to speed to get the precious work done and doing fights they should not fight. So what are the options to mitigate this here? Well, I don't know, but we can start to review some options. So on our beloved Apple platform, a substantial portion of the Mac users are using Macs because of the Unix environment. So this is key. And also a growing number of developers come to the platform every day. And they ask themselves how to get the tools. So they quickly look out for some package managers that should help them to set up their toolchain. And this is an example of Node.js. So, and you will find some instructions usually with a project, and very often you see Homebrew. There's also Mac ports, so there's some variations. So this tool, known as Homebrew, addresses a specific problem with an adequate solution. It helps to install additional Unix tools to your Mac. And it's a package manager that turned out to be very successful in the community and is widely used by developers all over. As mentioned, there's also other stuff that do the same thing. So what is Homebrew? Let's look at it. It can install some Unix tools that Apple didn't by default. So, and each package will come installed into a subdirectory structure of user local, and this gets then symlinked usually to user local bin. And it's mandatory that you have the Xcode command line tools installed. So, by default, Brew will always fetch the latest version described in a formula, so you will always get latest. And so, unlike the Linux or the known Linux package managers, Brew doesn't have an advanced cryptographic signature or GPG implemented. So, this is a project on Microsoft's GitHub, and let's take a look. So the first way to install Brew is curl to Ruby. It's a one-line script that downloads everything that you need to run Brew. It asks for some permissions and that it walks you through the process. However, as an alternative, you can use Git or Puppet with Git, and Graham Gilbert just updated some Puppet manifest recently. Once you have the tool, you can just run Brew and give it a command to install software, to uninstall, to update, to list what you have, and you could even use Brew to search for a piece of software. That will look like this. Brew install MySQL, and this will call up a formula with the name of the binary. The formula is publicly hosted also on GitHub. That's the Homebrew core, and there's nearly 4,500 whatever formulas available. So, and the GitHub web page can't even show you all of those files. However, there's an API, you can query that, and even the brew tool itself can give you a lot of the information. It's interesting to see how much this tool is used. So there's 1.5 million OpenSSL installs happening in just a turnover of 90 days. So this is a lot. It's a massive project. Let's just inspect a little deeper in how a formula is working. So you have you call the command brew install node for installing Node.js, and the binary runs an auto update on itself, and also shows the change formulas and any new things that happen to be listed in the public repo. It then fetches the dependencies that a tool needs, and finally installs the tool. So where does the software come from? So it's usually, however, brew can compile locally if you want to, with some extra flags, but usually a pre-compiled binary is fetched from a repository, which is run by JFrog, and it's called bintray. Okay, next. If you have MySQL installed, we need to learn the whole brew ecosystem a little bit. If you have installed MySQL, you probably want to have it run from the very beginning, or you want to start it up. So there's the brew services you can trigger for that. What is this doing under the hood is just like it installs a launch agent, or if you use root, it will install a launch daemon. So yeah, it has a little plist in XML that it will pull and just install. So you better inspect what's in this plist because it's running on your computers. There's a funny thing called Homebrew cask, and it extends into the install an app territory. There's 3,900, what is it? 3,966 apps that are ready to be installed, and they got a peer review of 5,586 contributors. Yeah, so you can install brew cask handbrake, and then you get some pineapples and cocktail cherries, or have to be insecure if this will target you. So let's take a look, because brew has an audit function. So what is it doing for us? We call brew audit handbrake. It asks for some permission, and it just says passed. Well, so how does this work? Every brew formula has a SHA-256 that represents the archive, and this is publicly available. So once brew pulled down the artifact, it will compare this hash, and if they match, everything's okay. So what are the extra safety measures that the volunteer team running brew are doing? So they have a presence at HackerOne. So if some people detect, oh, this is something not right with brew, they can just like alert there, and it seems that the turnaround time is quite fast, because a lot of people are using brew. But brew is convenience. It's not automatically all trustworthy, so it's not running in a sandbox. It's running on the computers. And you are responsible to have the according security measures in place for your organization. And, remember, the developers just do the updates individually. How do you gain control on that? That's a certain problem. As mentioned, the formula can compile locally. Again, if 50 developers compile locally, they may end up with binaries of probably a different fingerprint. So it's hard to observe what's going on in the details. So there's tools that can help for that. And developers love to do their own thing. They think, this is an awesome tool, and so everything is instantly available. So it seems that we have all the bananas we want to, and we're safe to drive. Well, what about scaling and about consistency in a deployment? This is a problem. How do you control and ensure that the same set of tools is used across all developers? So there should be something in place. The cool people already know that you can create a repository for that, and this repository is called a tab. So it can be extended by your own formula. So you have a mix of public and private binaries that you can just offer on the tab. And on the command line, the developers can switch between tabs. And of course, someone has to maintain the tab. And yeah, well, developers can override a tab anytime. If you say, hey, we're not fine that you're using this brewcast to install Chrome for yourself. We have Monkey, we have whatever. So they can override it. So brew is just like a very powerful tool. Cool. So this looks interesting so far. But there's, of course, more things going on under the hood. So permissions. Brew wants that the user who's using the tools owns the tools. So, and formerly people were doing like this, but in user local there's Monkey, there's probably osquery, there's other stuff living there, and we don't want that this is happening. So this hurts. So don't do this. It's much better that you just like follow the instructions that Brew is doing. So they have all the subdirectories, and please write a script that owns, or there's scripts available that give the permission for those subfolders to the user, but they will not touch all the other folders. Because you don't want to fight with Brew and how it works. So, because you can try to mess with it, but it fires back eventually. So, how to run a mass deployment? This is an interesting question because, yeah, we have a tab. We can tell the developers, hey, please use the tab. And I think in many organizations this will work well, but think about in the beginning where I explained there's living behind a proxy and living behind hardened firewalls. So this, yeah, this can be quite a ride. So sometimes you just look out for the bright people out there who have written some tools already. And so Tim has done a couple of them. And yeah, so one is BrewBus. Tim just started to work on that. It just builds, or you restarted to work on that, as I learned. So it builds just packages from Brew, including the dependencies, and it avoids that there's like collisions happening between the dependencies, because it could be that one tool requires OpenSSL, and the other tool requires OpenSSL as well, but probably in a different version. And so, as I understand, the BrewBus just like works around that. There's also BrewPKG, which is a bit more simpler, but it also helps you to create a quick package out of a Brew binary and includes all the all the dependencies. However, so Tim and I were just like looking out for something to solve it. So I was contacting him. Hey, Tim, you've written those cool tools. I probably have an edge case here with some customer scenarios. So what are your ideas? And we collaborated on a new tool, which is called Brewster. What is Brewster? Brewster is a monolithic package for a dev environment, and you can deploy it. So it helps to speed up the deployment with a more simplified process. So it's also, as there's reporting built in, you can run an audit trail also post-deployment if something has been changed in the tools you just deployed. And it's all based on Brew workflows. So you do get the original binaries and you do get the original dependencies, and you can enable to use that over a full fleet, but you don't have to use Brew on all the endpoints. You just deploy the binaries. So you practically can use Brewster to just like get rid of the dependency of using Brew on all systems. However, this could be a good thing, this could be a bad thing. So Brewster is obviously written in Python. It's, as mentioned, it builds a single monolithic package that helps to unify the deployment process. And you have the same set of binaries you put out to all the developers. And this was the main purpose that should be solved here. And it has reporting built in. It has some dependencies. So Google Santa is used to just calculate checksums for all the files. Yeah, it is also critical that you need to test this in your environment. So I think it's interesting to see a little demo here, how this monolithic concept can be applied. And I know it's a bit strange to run a monolithic packaging. So as mentioned, this may not work for you, but it has solved some problem at clients. So this is a list of brew tools, of binaries that you want to install via brew. So this could be a much longer list. And so the conditions are, in this scenario, brew is installed on an admin computer. You have this list of binaries that brew should install. And you call up the Brewster tool. And as a result, you will get a package with all the content. Let's go. So it's working, yeah. These are the binaries, so like and, groovy, nvm, pyenv, Python 3, and wget, and tree, and all of that. So you call the tool, Brewster, and you provide the text file, and you provide a directory, the right one, where to install. So the tool is starting, and it uses brew, it triggers brew, to just uninstall any previous versions, and then it fetches the new versions just straight from the list. So they are downloaded from the bin tray repository. You also see some information on the caveats or some special settings. So this is just like the very verbose log. And so it's purring all the dependencies, downloading all that stuff. This takes a moment. It's crazy how fast the Python install has been since the latest changes. And it also runs some tests on the binaries in a short moment so that you can actually know that the binaries will work. Those tests are written into the formulas as well. So, and we're nearly there. So and works, and NVM works, pyenv works, Python works. So, and now it's just like creating us a big monolithic package. And that should be done in a short moment. Come on, yeah. So now we should be almost ready. Yeah, the package is there. Yeah. And we see the output, which gives us our Brewster package that contains everything in here, in this structure, all the dependencies. Then the debug log, what we've seen just in the terminal. All the formula versions, so this is nice to diff if you make another build the next day. A full BOM, so everything that's in the package, and a report JSON file that you can just process with other tools as well. So, and as mentioned, so there's the dependency of Santa that it calculates the checksum for every tool, every file. So before you deploy this package to your fleet, you already know the fingerprints, and you can verify it afterwards. So on a client, if you deploy this, just like look at this user locals folder, which is having a couple of subfolders, and more will be added to by deploying this package. So it's a quick install. This is a 100 meg package. And so in a moment, you will see, yeah, it's all there. As mentioned, the user has to own these packages. So, but once they do have the ownership, they can just call up the binaries without using brew on that client computer. So I think, yeah, that's it. As mentioned, there's this reporting with all the details we get from the brew formula, as well as combine it with the stuff that Santa is giving us per binary. And you can double check what you have deployed with a tool like OSQuery. So post-deployment inspection. And of course, OSQuery is a nice tool to give you even more information. And yeah, so indeed, the reasoning behind working on this tool are somehow driven by this living behind the proxy. And for this reason, the monolithic workflow came up. So it's a strange parrot, but it works in those environments. And especially if you're working in lockdown and air-gapped environments, it's useful to have a tool like this. So it mitigates that you have a unified brew deployment. And as you build the package, also behind the proxy, it takes a moment, but that's the work of one person. And so you play literally by the rules. You don't bypass anything, because that's not allowed in restricted environments. And in the end, on deployment, you save a lot of time. So you already acquired all the information on the binaries, the fingerprinting, so you can double check if something was altered or changed. And yeah, so as the people don't use brew anymore, you don't have the problem of a misuse that the people go for, reach out for cask and install some software. As mentioned, post-processing is required. It will break a current brew install. So this is just like, yeah, dangerous territory. Because if you screw something up, you're responsible. But it's open source, and yeah, you can improve it. It will become open source. And we thought that it's much better that the developers own this tool, and they run the process, they check the package, and then they just hand it over to IT to deploy it. So yeah, and that's mostly it.